Okay, thank you, Cloud Person in the data center. Let's adjust this. Excuse me. And let me hide the meeting controls. All right. So good morning and happy Monday. I will apologize ahead of time for my voice. Still have a cold. I've been pumping massive amounts of turmeric and ginger into my system, kind of home remedies, to try to alleviate this cold that I caught yet again from my elementary school age daughter. But that being the case, today, excuse me, we'll continue on where we left off with the material on merging for data frames. And then we'll pivot to a module concerning posing your own questions. Prior, or at least throughout the semester, you've been given the questions that you ask of your data in your data science process, but we will also consider today, as time permits, considerations for posing the question. It applies both to the cases where you have control over your data, meaning that you're the one who builds your data set through something like a survey, and when you're just given a data set, which is mostly the case for this class, but it's still important information to have. But before we begin the usual administrative bits, the reading, of course, will be updated in the next module after this. It's already updated on the course. I keep saying Moodle in my head, Canvas site. Project number 3 is due tomorrow at the usual 11:59 seconds. Any questions about project number 3? How's that going? So? Okay. So save yourself the time. And if you download the data for the entire period, download that once and brain hiccup. And this divided up into epochs in time concerning pre-COVID, COVID shutdown, and COVID recovery, as we've been calling them. Okay. I will certainly be available. The TAs are available, and the TAs are excellent students. And it's on purpose that they're not computer science students, because data science is interdisciplinary by its nature. And I've found them both, Elizabeth and Diana, to be quite good. Excellent. All right. Any questions? No? No questions about Project 3? All right. Okay. So why don't we continue on? So when we last left off, to jog your memory, oh, yes, I totally forgot. So as of the end of today, we have 6 weeks left in the semester. That happened really fast. So we'll be pivoting the course to material concerning something called max likelihood estimation, and then spend the balance of the semester on the data extraction side, mostly machine learning and data mining types of methods. Okay, so where we last left off, we talked about the merge, and we kicked it off with a refresher on the anatomy of a data frame, the so-called star of the show for the Pandas API. And for the data frame, of course, we have a dictionary of lists as its implementation, and each one of those lists represents the record information for each column, and the key for each of the dictionary represents the column name. And so when we merge, we're enterprising to put together all of the records in the so-called left data frame and the right frame in a principled manner. And there are umpteen many options that you can specify that define the criteria employed when you're admitting records from the left frame and the right frame to the resulting combine. Okay. Any questions about this? Okay. And so I have a piece of ginger in my mouth. It's just just stuck there. Excuse me. And so we talked about the API at a high level, and I won't kind of spend all the time on that, but just the 2 or 4 that are really important are the left on and the right on options. And these are intended for you to specify the key names for the left frame and the right frame, whose columns are going to be the criteria for the merge. Okay. And so you're going to merge based on records that occur in the left frame and the right frame. And how you specify them one way is with the left on and right on. And so the reason for that has to do with the default behavior. The default behavior says that when you're going to do the merge, of course, you specify columns. And if those column keys are the same alphabetically in the left-hand frame and the right-hand frame, it'll assume that that's going to be the criteria for left and right used for merge. But it's not always the case that you're going to have the same key names for the left and right frame as used as the basis of your merge. And so it gives you the opportunity to say, use this key for the left frame and that key for the right frame when you're going to do the merge. Okay. Any questions? Jar your memories. That make sense? Okay. Likewise, you can merge additionally on the index and not just on or instead of the keys. And as we said, each data frame starts with a default index, and that default index is a natural number representing the offset within each one of the lists corresponding to the columns, the offset corresponding to that particular row's worth of data for that 2D data structure. And so if you were to merge based on the index, be it the default index or some other non-default index, if you override the index, for example, with the date stamp, you can specify the name of this index used as the basis of the merge. Okay. Any questions? No? All right. And so the type of merge, or how, not type is how you specify the criteria for the concatenate, which is a special case of the merge. But for the how parameter, that specifies the criteria employed when you're deciding which records from the left frame and the right frame you're going to admit to the resulting combine that you're trying to build. Okay. And so the inner join, or the so-called inner join, says whenever I admit records to the combine from the left and right frame, I'm going to employ a so-called AND criteria. So that means the values in that particular column corresponding to the key you're using for the left and right frame, they must be the same or be present in both of the lists contributed, or both of the lists used for the join in the left frame and right frame. Does that make sense? Okay. Likewise, the outer join replaces our criteria or changes it to be an OR criteria. It doesn't matter if it's in one list, let's say the left frames list, and not in the right frames list. You just need to satisfy an OR criteria. So it admits all of the records to the combine, regardless of if they're contributed by the left and right frame, just the left frame, or just the right frame. And then these last two, left join and right join, they start out by populating the resulting combine, in the case of left join, with the contents of that column or the records based on that column for the left frame. And then it iterates through that particular column in the right frame and populates the combine with records that are also in the left frame or that are in the combine at the moment. Okay, does that make sense? Any questions? And then there's a right join, which works just like the left join, but instead of populating the combine at the beginning with the left frames records, it's going to populate it with the right frames. Now, conceivably, you could just always do a left join, but just reverse the parameters, right? And it's the same thing. But nonetheless, they've chosen to implement the left join and a right join. Okay, any questions? No questions? That makes sense? No? All right. So where we left off last time, we had an example, and this example had 3 data frames, and it's on purpose that I show them to you as a dictionary of lists. And we have 3 frames. One is books up top. We have authors in the middle, and we have sales down in the bottom. Let me choose blue here. And so for books, we have a numerical column, and the key name is author ID. Okay. Then we also have another numerical column, book ID, and you can think of author ID as like your one card ID number. The book ID, you can just think of it like an ISBN number. It's just an identifier for a particular book. And then the name is a string name of that particular book. And so as a data frame, positionally, the first position in the author ID list corresponds to the first position or 0th position in the book ID, which corresponds to that first string intro to Python. Okay. And so likewise, we have the author data frame and we have an author ID, a name column as well. So it only has 2 columns. And then this last data frame, sales, it has 3 columns. One is the author ID, other is the book ID, and the last one is sales, which represents the number of units of a particular book that was sold, where book is identified by the book ID and the author who wrote it is identified by the author ID. Okay, so if we print these out, and then here in this kind of eerily similar to Python pseudocode, we're just going to show the first 2 rows of the resulting data frames for books, authors, and sales. Okay, any questions? No? And so let's continue on with the merge. And I've repeated the data frame, just if I need to flip back and forth, it's a lot easier to do it from here. And so here we're going to start out, we're going to do a merge. And so we're going to specify the books data frame, that's frame 1 here. And we're going to specify the author's data frame. Let me remind myself, that's the second data frame here. So our left frame is going to be the author frame. Our right frame is going to be, the left frame is going to be the books data frame. The right frame is going to be author's data frame. And so we're going to build our combine. And here you'll notice there's no option for the join type. And so if there's no option for the join type, the default is an inner join, which we said implements the AND criteria when you're going to build the combine. So here we have books, our data frame. And then for the right, on the right, we have authors. I'll just abbreviate. And we're going to build our combine. And we're going to specify the AND criteria, which is the inner join. Okay. So now we have the scenario. You'll notice here, left on is the key name string, author ID. Right on is the key name, author ID. Now here, okay, if we look at author ID, all right, it's the string author ID, there's author ID. Let me flip back and I'll show you the full contents of the author ID. So in books, our author ID is 1, 1, 2, 3. And in authors, our author ID is 1, 2, 3, 4. So they're different from one another, right? Here we have author 1, author 2, and author 3 are present. Those are unique, 1, 2, and 3. But we have 1, 2, 3, and 4 in the author's ID list for the author's data frame. And so now when we build this combine, because it's an inner join, it's going to look at the author ID, and I'll just repeat author ID in the books. It's 1, 1, 2, 3. So we have 1, 1, 2, 3. And then we have, I think it was 1, 2, 3, 4. 1, 2, 3, 4 in the author ID. And so because left on is author ID, it's going to take that column, that data, 1, 1, 2, 3, and right on is author ID. It's going to take 1, 2, 3, 4, because that's the list associated with the key name author ID in the left-hand frame and author ID from the right-hand frame. So now it's going to employ this AND criteria. So it's going to go through and it's going to say, okay, well, 1 and 1, are they both present? And yes, they are. So that first entry in the data frame, that first row's worth of information is going to be admitted to the combine. And remember, it's the entire row's worth of information. But the criteria employed for admission of a record from the left and right data frame is that particular unique item in the list for author ID present in both the left author ID and the right author ID. Does that make sense? Any questions? No? So you'll notice here then we have another one. Well, one is also present on, it's not present on the left. It's also present on the right. Two, two, yes, it's present on the left. It's also present on the right. Three is present on the left. It's also present on the right. But four, wait a minute. It's present on the right, but it is not present on the left. Does that make sense? All right. So now when we look at the resulting combine, we see there are records contributed by the left-hand frame and by the right-hand frame based on that and criteria. So here we see author ID 1. We see author ID 1. We see author ID 2. We see author ID 3 because those match the and criteria for the basis of whether you're going to pull a record into the data frame. So we have associated with that a book ID. Now, book ID, if we look back, book ID was contributed by the left-hand frame. Anywhere you see an author ID of 1, because it's present in both the left and right frame, that book ID, that everywhere we see a 1, that same record contributed by the left-hand frame is going to be admitted to the resulting combine that gets built. Does that make sense? Yeah. Likewise, this name, Intro to Python, we'll notice that is a record or row from the left-hand frame associated with places where the author ID is 1. And because the author ID of 1 is admitted to the resulting combine, so too is that name, Intro to Python. And then lastly, we see in the right-hand frame, author ID 1, yes, is admitted to the resulting combine. Everywhere we see author ID of 1 in the right-hand frame, it also contributes a record from the name field in the right-hand frame. And so here we see author ID 1, book ID of 1, that's contributed by the left-hand frame, Intro to Python, that's contributed by the left-hand frame, author ID of 1, that's contributed by the right-hand frame, and good old Nick, whoever Nick is in this example, is contributed by the right-hand frame. Does that make sense? Any questions? No? All right. So I wasn't going to do all of them just in the interest of time. But the thing I will also direct your attention to is you'll notice the key used for the left frame and the right frame is author ID. Okay. So we have an author ID column here in the resulting combine. That's because of the left-hand frame. We have an author ID here in the resulting combine. That's because of the right-hand frame. But we also, if you notice on our left-hand frame, we have a name field. We have another name field as well in the right-hand frame. Now, all of the columns that are pulled in to the resulting combine, sometimes they're going to have the same key name. And because they're pulled in as a result of the merge, not the thing that was based on the key, you need to have a unique name for them when you build that combine. So if we go back to our API documentation, I wish I had copied that, for the merge, we notice this option, suffixes. Now, the default value of suffixes is a tuple, so the order matters. We have underscore X as in string and underscore Y as a string. So what it does is anytime a column is pulled in to the resulting combine, if there is a collision, meaning the same name or key for the left hand and the right hand, it needs to distinguish it, and it does that by appending these suffixes to those key names. And so here, the left frame will maintain its key name with an underscore X tacked on to the end, and the right frame will maintain its key name, and it'll append an underscore Y onto the key name. So if we go back to our example, we see here, name is changed to name underscore X, and that was this name field from our left-hand frame for the merge. And then name contributed by the right-hand frame here had appended to it the suffix underscore Y. And so now they're unique. Okay, any questions about this? Does that make sense? And so I really encourage you to walk through an example and ask the runtime, right? Fire up a Jupyter notebook, which we'll do, and try this out and convince yourself that it's doing what you think it's doing, making sure you pay attention to what the underlying data structures are and what the algorithm underneath might be doing. It's really important to get into that mind space when things go wrong, right? To help you debug issues if you don't get the results you think you expected, or if you get some sort of syntax error. Okay. And you'll notice here, author ID 4 is not included. Here we have no author ID 4, whereas in the original definition, in the author's data frame, we had an author ID of 4, right? Because it doesn't satisfy the AND criteria for the inner join how type. Okay. Does that make sense? Any questions? No? All right. So let's go to this other example. And here it's the same with one exception. We have the join type change. We see the option how is now set to outer. The default is inner, but now that we set it to outer, it's going to change the criteria used when building the combine. So again, we have our left-hand frame, left. We have our right-hand frame, right, and the left-hand frame is books. The right-hand frame is authors, and we're going to use the ID, author ID field, as the basis of our merge. And so we had 1, 1, 2, 3, 1, 1, 2, 3 in the left-hand frame, and we had 1, 2, 3, 4 for the author ID for the right-hand frame. Okay, so now we're going to build our combine, and because we've overridden it to the so-called outer join, that implements a logical OR. And so with the logical OR, it has to be present in just one of them. It doesn't have to be the item or the value or the object, doesn't have to be present in both for that particular row worth of information from the left frame and right frame to be admitted to the resulting combine. Does that make sense? So again, okay, we have a 1. Well, it doesn't matter if it's present in the left or the right. So 1, 2, 3, and 4. 4 satisfies that OR criteria because it's present in the right frame, not present in the left frame, but this is an OR criteria, namely the outer join. So it's just like before, but we see this entry here, author ID 4, is now present, whereas for the inner join, it was not present. And that's because it satisfies this OR criteria. It's present in one or the other. It's present in the right-hand frame's author ID column. And so if we do that, okay, so we pull in all of those records that have an author ID of 4, okay? Well, if we go back to the original definition of the data frame, author ID of 4, okay, that's that last position in the author ID array. We're also going to bring in the other record in that author's data frame, and that's going to be the name Evan, okay? And so when we go forward and look at this, you'll notice we have author ID of 4, and we have a name of Evan, and these are contributed by the right-hand frame, where the left is the authors, rather books, I keep saying authors, is the books frame, and the right here is the authors frame. And so here, author ID of 4 and the name Evan is contributed by that last record in the right-hand frame or from the right-hand frame. But then for that particular record, we don't have an author ID of 4 and we don't have a book ID corresponding, nor do we have a name for the name of the book contributed by the left-hand frame. But it still has to build that entry. So it's going to fill in the nothing entry. So we get not a number contributed to the resulting combine by the left-hand frame books for both the author ID, the book ID, as well as the name field. And again, we're using the default behavior for suffixes. And you'll notice the name field has a underscore X as a suffix, and then for the left-hand frame's key name, and we have an underscore Y for the right-hand frame. And again, it's because we have this identical key name on the left-hand and the right-hand frame. So we need to distinguish them, and it's done using that suffixes option. Okay, any questions about this? Does that make sense? Okay. So here, we're going to make one more change, and we're going to change the suffixes option in this merge API. So this is using the default, but now we're going to change it. So what do we see? Now we give it a tuple, suffixes, and the assumption, again, tuple, it's an ordered pair, so order matters. The first item in the tuple, that's going to be the suffix for the left-hand redundant key name. And the second value in the tuple is going to be the suffix for the right-hand key name in order to make it unique. And so if we replace left suffix with book and right suffix with author, now when we get this redundant field or key name admitted to the resulting combine, we see it's the name key name contributed by the books frame, and it's the name key contributed or originating from the author data frame or the right-hand frame. Does that make sense? Any questions? No? And so the merge, it builds the combine based on a key, and that key represents the information source to which the criteria associated with the how is applied to decide whether or not an entire record from the left frame or right frame should be brought into or admitted to the combine that you're trying to build. Okay. Any questions? Does that make sense? Okay. I was wondering why you're blurry because I didn't have my glasses down. All right. And so, why did I do that? Yes. One of the things you can also specify is a so-called compound key. And a compound key is very useful when the information in one column, as identified by its key, is not sufficient to uniquely define the records that you admit to the resulting combine. And so here we call merge, and for our left-hand frame, it's going to be books. So that's the first frame. Right-hand frame, in this case, it's going to be the third frame, sales. So this is books, and I'm really doing this for my benefit, books. And this is sales. Okay, so you'll notice that the how is not specified. And if the how is not specified, you can use the default how is equal to inner. And inner join employs an and criteria when you're deciding whether you should admit records from the left frame, right frame, based on the key to the resulting combine. And so here we have our left frame, and I'll draw it over here because I need it a little bit bigger. And we have our right frame, right? And this is sales. And this is books. Okay. And you'll notice now our on has this list, author ID, and then book ID. And so this is like saying left on, right on equals author ID. But if we did left on, right on is equal to author ID, it's just a single column that's used as the basis of the merge. So if we look at author ID alone, we have author ID here. I should circle that in red, make it a little bit different. We have author ID here from the left frame. It was the books frame. And we have author ID here from the sales frame. It was the third frame. And let's make some observations here. So we have author ID of 1 and 1. Okay. Author ID 1, 1. We have 2, we have 3, and we have 4. But if we look at our author ID, it's not enough because we notice that we have, let's see, Let's see if I can remember this. 1 and 2, 2, 1 and 2, book 2, 2 is Python 201, author ID 2. I forgot what I was going to say. The author ID is not unique enough to distinguish the authors and to describe uniquely the authors and the books. Okay, so let me just carry through the example. So here we're using an AND criteria because it's an inner join. And so we have our author ID. We have 1123. That hasn't changed from the books frame. But when we deal with sales, okay, the author ID in sales is not unique enough. So if we specify author ID and then book ID, the following is happening. So here we have author, and then we have our values here in author. And then here we have book ID. I'll just abbreviate that. Here we have author, and we have book ID. Okay. So now what it does is it defines a unique key or criterion for the search, not based on one column, but based on two columns. And so if we had, for example, and I'll just talk about the positions and not the values, we take our first position. Let me do that. 1, 2, 3, 4. 1, 2, 3, 4. All right. Let me change my pen color. Ooh. We start out with our first author ID, and then we say for our first value of author ID, take the first value of book ID. And that's going to be the criteria I use to check whether a record should be admitted to the Combine. And then I take author ID, the first one, and pair it with the second one from book ID. And that's going to be the next piece of criteria I employ for whether or not a record should be admitted. And then I take the first one, pair it with the third, first one, pair it with the fourth. And then I switch to the second one and do the same thing. And then the third one and do the same thing. And the fourth one and do the same thing. So essentially what I'm doing is that when I talk about the key value and employ the AND criteria, because it's an inner join, as to whether or not that particular record should be admitted to the Combine, I'm not just using data from one column. I'm using data pairs in this case from the ID column, the author ID column, and the book ID column. Does that make sense? Okay. And so when I do that, you'll notice if we observe in the resulting Combine, we have a single author ID, we have a single book ID. We no longer have author ID and book ID from the left frame and from the right frame. It's also an inner join, so it's and. And you notice I have 1, 1. I have 1, 1, 1, 1. I have 1, 2. Then I have 2, 1. I'll have 2, 2, 2. Then I'll have 3, 1, 3, 2, etc. Right? So we're using this scheme to define pairs of keys, values, used to decide whether we admit the resulting record to the Combine. And it has to be an and criteria. Is it present in both the left-hand frame as well as the right-hand frame? Does that make sense? Okay. So now we also pull in the other records or the other columns because the criteria says if it's an and it's true, then you take the entire row from the left-hand frame and you take the entire row from the right-hand frame, only if that compound criteria has an and satisfied for the left and the right-hand frame. So let's take a look at an example here. And if we go back, we have author ID is 1 and book ID is 1. So 1, 1. Is 1, 1 present in author ID, book ID for the sales frame? Okay, so we have 1 paired with 1. Yes, it is present. Okay, if it is present, we're going to bring in sales, which is 10. If we look over here, 1, 1, sales, which is 10. We also bring in intro to Python because it's in that first position of the name column. Does that make sense? So then we say, okay, well, if 1, 1 is there, what about 1 and 2? Is 1, 2 present in books? Yeah, that's where it came from. Let's look for 1, 2 in the sales frame. The next position, 1 and 2. Oh, wait, 1 and 2 is also present, and it's true. So we'll bring in the second record here from sales, that's 20, and we'll bring in the second book string, which is Python 201. If we go back, we have Python 201, 1, 2, Python 201, and we have sales of 20. Does that make sense? Any questions? So it's using more than one column as the basis for the operation type, whether it's an inner join, an and criteria, or an outer join, the or criteria. Okay. Any other questions? No? All right. And so merge is one of the more confusing features of Python, hence the concatenate. Concatenate is a special case of merge. All right. But merge is a very powerful mechanism, especially when you combine that with ingesting data from a database. You can do SQL, standard query, structured query language, to pull in data into a data frame and not just from a CSV file. Okay. No final questions? No questions? Make sense? Hopefully I've explained it well enough. It's always confusing. All right. So with that, we will move on to the Jupyter Notebook. Almost forgot. So let me end the share here. And every time we release the pen, every time I stop the share, PowerPoint for some reason drops the other shares. We have somebody on. So let me do this. Let me keep my annotations. Let me bring the Jupyter, oops, stylus is over there. Let me bring up the Jupyter Notebook. I'm gonna reshare my screen. Let me see, how do I do this? Let me do that. No, how in the world, what did I just do? I don't want to do that. How do we make this bigger? Oh, let me do that. There we go. Share screen. And it's a faculty no-no to share the whole screen because I wouldn't want a sensitive email or anything to pop up on the big screen. All right. So now we have our Jupyter Notebook up. Let me maximize that. And let me hide the meeting controls, time check. There we go. Hopefully that is front and center. I think so. Yeah, I'm screen sharing. All right. So we start out and just going to import pandas. And we're going to define the 3 data frames that we saw before. And so we have the books, we have frame, we have authors, and we have sales, just like was described in the examples in the slides. So we can print the whole thing and just printing the first 2, but it's conceivable because they're not that big. We could print all 3 of them. So let's go ahead and do that because we can. So let me run that, imports, create the frames, and let's print them all out. And so, of course, here we have our books frame. Second, we have our authors frame. I should put a space between them. How do you do that in Python? I think it's empty print should do it, right? No, \n. I'm such a Java person. I feel like I'm like bilingual and translating every time I write Python code. So I think natively in Java. There we go. Okay. So we have our books data frame. We have our authors data frame, and we have the full sales data frame. So now we're just going to do a merge, and we're going to take the default, and we're going to do an inner merge. So that's going to be the and criteria, as we had described. And then we're just going to print out the result of the merge. And so it's just like we had talked about on the last PowerPoint slide. So let me go ahead and change how equals outer. Okay. And let's look at the result. You know what? Let me do that. Let me not do it here. I'm going to do it separately. Excuse me, so you can see the difference. So, excuse me. Let's see. how equals outer join. So that's the and criteria. So if we go ahead and we use the the or criteria is outer. So if we use the default, which is how equals inner, that's the and criteria. And if we do outer, what just happened? Oh, I didn't print. Silly thing. They only do what you ask them to do. Merged. All right. So, and now if we do the outer, you'll notice here, because it's an or criteria, for author ID 4 and book ID 1, there's no name there, right? It's not defined in the author, the book's frame, but it is defined for 1 for author ID, book ID keys. It is defined in the sales frame, and it's associated with sales of 10. Okay. Any questions? Does that make sense? So I really encourage you to, type this in, ask the runtime to get comfortable with it, and get into an exercise of looking at the left frame, looking at the right frame, looking at your options, writing down your criteria, and then deciding what the resulting combine should look like before you print it out, right? It's a great exercise. Any questions? Does that make sense? Yeah? All right. So let me stop the share again, yet again. Let me redo the share, and I'm going to bring up, let me save that. I'm going to bring up the other PowerPoint. Voila. All right. So let's see, share the screen. And here's my other PowerPoint. Let me screen share. Let me make sure this is in the foreground. Just because we see it doesn't mean that Panopto sees it when we do the Zoom record. Okay. So check, still there. Sound is on. Let me go ahead, hide the meeting controls. Let me make sure this works. Okay. So today we're going to comment on considerations for how you pose the question. And so this all lies in an area called survey design. And we can't possibly do justice to a survey design course that you would get in social sciences and medical sciences and things like that. But this is just to kind of try to give you a prescription, as it were, for how you think about data problems. Because at the end of the day, the whole purpose of the data science process is ultimately to make a statement, data-informed statement, that addresses some question. All right. So before we begin, we're moving right along. And I've posted a book on probability, and we're going to be using that to talk about various so-called distribution families. We're not going to talk about distribution families today, but we will start with work on Friday for distribution families. And I like to assign the reading ahead of when we talk about it, so it won't be completely blank slate. And so it's a really accessible book, as accessible as a Prob and Stats book can be. And it's also free, available in PDF form. And I've posted the link on the Canvas site in PDF form from University of Michigan. Okay. Project number 3, of course, it's still due, 6 weeks left in the semester. We already commented about that. So when we talked about the first module in the semester, when we talked about the data science question, we said you begin with posing the question. And so up to this point, the question has been given to you, and you've enterprised to investigate using various analytical techniques, transformations, visualization, analyze the data in order to answer the question. But what happens when, it's usually the case, what happens when you're tasked with going out and finding the question, the quote unquote right question to ask? There are a lot of considerations there. And so the asking the question part of the data science problem, frames the problem that you're trying to solve. It's the whole point of why this is a science, right? You're asking a question, and then you're applying techniques, understanding what those choices mean, what they do, and using what you find to answer a question. And so it goes back to populations. And earlier in the semester, we talked about this idea that a population is a collection of all the possible units of interest about which you're trying to answer this question. And so you, for example, let's say somebody in dining services observe that there's a lot of food waste in the dining hall. Now, not only is it expensive because you're buying this food as an institution, an organization, and it's just going to waste. It's also expensive, not just because of the food that's being discarded, but also the labor that goes into it, right? The labor cost is far more expensive than the individual food item cost when you amortize it. It also fills landfills unnecessarily because it's food. It decomposes very nicely in a couple days. And also there's wildlife and there's other uses for that food, both feed as well as fertilizer and things like that. And then it's also, if you think about it, it's pretty shameful, right? Right here in Worcester, around us, literally a few blocks radius around, there's a high degree of food insecurity, right? So it's pretty shameful to have a lot of food waste at an organization the size of Clark University when there's so much food insecurity right here around us. And so suppose then you observe a problem. And that's usually where posing the question arises. It's out of some practical problem. Now, in this case, the good news, at least this example we're going to talk about at a high level, you have control over the data available to you. You can design a survey, and that's what I want to motivate. And with that survey, you're going to go out and you're going to sample that data. You're going to create that data set. And the goal is to try to make a statement about how some system operates. Okay. And any questions? That makes sense? Yeah. So we talked about a parameter as being some descriptive numerical characteristic about your population. The good news, the bad news rather, is that you don't have access to these parameters. But the good news is that your data can tell you information, and you can use that information that you're told from your or by your population in order to try to determine good proxies or substitutes for these hidden parameters. So for example, you might enterprise to describe, well, why is there so much food waste? Maybe people are missing meals, right? So you might, floating out there, try to figure out what the average commute time to campus is. Because it's not just, people who walk from the dormitories. There are people who live off campus. There are people who commute, but they still participate in the dining services. So floating out there are these ground truth values, like the average commute time or the number of times on average someone misses the dining hall hours. But you don't have access to it, so you sample. So you can think of your population as being structured in some way. And it's up to you if you're going to design a survey, get samples from your population, you have to study your system, right? This is where the domain knowledge comes in. So you can think about your population as being structured, comprised of a set of subgroups, making up what is possible when you try to encounter individuals from your population for the purposes of data collection. So being a university, right, if you weren't familiar with university structures, you might look up something like student status, freshman, sophomore, junior, senior. Now, how you structure your population has a lot to do with what you're after. So let me ask you a couple questions. We'll have a discussion. Does the student status have any relationship to the dining hall hours? Does it have any relationship? What do you think that relationship might be? All right, some classes, yeah. Fully on the dining plan. So there's a requirement, regardless of whether or not you actually want to use, what is it now, 20 meal plan or 14 meal plan or things like that. Okay. What about when the classes are offered? A lot of those first year classes tend to be closer to the morning, right? Except for this one, but I had no control over that. And so You see a lot of the seminars that are senior seminars and those advanced courses tend to be more in the afternoon, right? And so maybe it's the time. And so when you think about the structure of your population, you don't just look at the organization. You try to propose structure on your population under study that might, or you think might have some bearing on the issue that you're enterprising to study. Okay. What about residential versus consumer? That's another way we might think of the population of students at Clark. So let me ask you, how might this status impact whether or not you make the dining hall hours or food waste in general? Yeah. Mm-hmm. 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 Yes. Uh-huh. And so you go for the convenience, perhaps things that are closer to where you live, or just even the supermarket, grab it from the fridge, grab it and go, like I do all the time, right? Prep like on Sundays and stuff. Or what happens if, for example, at the Hyatt Middle School down the street, there's a fire bell. All of a sudden, uh-oh, right? It's right there on the street, so there's no like real schoolyard, and they're gonna block the traffic on the street in order for the various parts of the school to get out of the building and congregate in their gathering spaces, right? There might be some unknowns that happen, right, as well. And you might enterprise, in addition, to go to the dining hall and miss it because you're stuck in traffic and you know, like, ugh, I don't have time to get breakfast. Let me just go ahead and park and get the class because the window of time is gone and the class starts in 5 minutes. Whereas I was sitting here on Main Street on South Main for half an hour, right? Which has happened to me. Well, not the dining hall, but the half an hour on Main Street. Okay. What about this demographic? You have students, and I've learned that Clark has one of the highest percentages of international students among colleges in New England, which is fantastic. So you might have international students, okay. You might have domestic students. You might also have something that's kind of in between immigrants. They're kind of domestic students, and at the same time, they're just like the international students. So, how do you think this might impact food waste, or what relationship do you think, or bearing on food waste, do you think it might have? You think it has one? No? So, what about tastes, right? Because various people, even domestic, if you're from different parts of the country and you have certain tastes, if what's in the dining hall does not match with your tastes, then there's going to be some food waste there, unfortunately. Okay. Now, your populations are so-called hierarchical. That means your population consists of a set of subgroups, and in these cases, these subgroups are non-overlapping. And that's a gross oversimplification. It's not how it works in the real world. You can have people whose statuses intersect in various ways. Okay. So here's another visualization of the population. In this case, it's overlapping. And I like to think it's a little bit more representative of what an immigrant student is at Clark or any university. You kind of have the international students, those who come to the university from some other locale for university. You have domestic students, and then you have immigrant, which is kind of like this hybrid. You're both an international and you're domestic. Okay. Now, certainly for the membership in this mixture in between, in the overlap, you can have degrees where somebody's immigrant status is closer to being international. Maybe he or she is a more recent immigrant, or domestics, he or she is a less recent immigrant, has been in the country much longer. Okay. So in the idea then of how to structure your population, you can have a non-overlapping, two-way overlapping, three-way overlapping, 10-way overlapping. It doesn't matter. And so thinking about the structure of your population, you are going to do some research, yeah, but it's important to represent them because it helps you to decide where you're going to spend your resources. And I'll get to that in a slide or two. And so you start out with your system. You hypothesize from study what the structure of your population is, making sure to choose different demographics, as they were, based on how relevant you think they are to the issue that you're investigating. Okay, and so I looked it up at Clark, and there are all sorts of different statuses that students at Clark might fall into. And these so-called demographic studies don't just refer to attributes of the person, they can also refer to practices, they can refer to status or categorization at the university. Okay? All right. But nonetheless, it really requires you to understand your system under study if you're going to create your data set in order to ultimately answer the question informed by data that you're enterprising to ask. Okay, any questions about this? And if you take my Internet of Things course, we go over a method called design thinking, where you go through the empathy phase and you interview people and you come up with these demographics and then you design your population and then design a survey and deploy it and all that good stuff. All right. So imagine you have some complex, overlapping hierarchical population and you have finite resources, you have finite budgets. Maybe you have so many grad students or students with which to conduct your survey. Maybe you only have half a semester to design and deploy the survey, and you spend the other half of the semester analyzing the data, right? And so you have finite resources in the real world, and so you sample, and then you collect data, and you keep doing this, rinse, repeat, and you want your samples to be representative of the population. Now, before, more theoretically, when we said you sample, we say you don't have preference, right? You sample at random without preference for particular members of your proposed population for your system. But in this case, you're going to use the demographics that you believe your system has to bias your samples. Because you have finite resources, you can't afford, for example, 10,000 samples, an arbitrary number. You have to very judiciously place your samples distantly from one another so that you can have good representation of the underlying proposed population. So in a place like Clark, if you were conducting a study by issuing a survey, you're going to choose the time of the interviews for the survey, the location, as well as the number. And so if it's freshman classes, if they're early in the morning, you're going to have your surveys early in the morning in the places where freshmen go. If it's commuters you're interested in, maybe there's a commuter house, I don't know if there is here, but you're going to perhaps have people doing surveys at the commuter parking lot. So as people are leaving, walking out after parking, you can contact them and collect your survey information. And so when you place your samples, you use your population to guide your sample placement. It's not really random. It's this idea of equidistant in terms of the different demographics, time, venue, and number, so that you can have representation among all the subgroups, regardless of if your population is overlapping or non-overlapping, and certainly hierarchical. All right. Any questions? Does that make sense? Now, my last version of data science course last semester, I had them do a survey. It didn't work too well because it just wasn't enough time. So I dropped that part from the course, but certainly we're going to talk about it because it's important information to have. All right. And so when you take a survey, considerations, of course, it's typically driven by a problem, right? Some organization sees something happening and they want to understand how it works and why it is the way it is because they want to make a change. So if our issue is that there's high food waste in the dining hall, with this system, well, you want to know what it is you're studying. Well, you're studying Clark University, more specifically dining services, but you also want to know who's touching the system. Excuse me, who are your stakeholders? Now, for any stakeholder for a system, you're going to have three major categories of person that touches the system. And it's not just these three. It's at a high level. You could certainly have increased specificity. You can have users of the system, right? Those are the students who go into the dining hall. You have operators of the system. Those are the people who are responsible for running the dining hall, and it might not be people who you think. And those that manage the system, those that are responsible for the decisions that make the system run. And so certainly users of the system include Clark University students, but it might also be admissions, right? You see all these tours, people coming into the dining hall. They might be eating, maybe they give them lunch, I have no idea. But certainly admissions folks, when they give tours, they're users of this particular system, dining services. So then you have the operators of the systems. Those are the individuals or principals who make it work. You have the dining staff, both people serving and cooking. You have facilities, right? Because you have to clean it, you have to maintain all of the equipment. Those are the operators. You have those who do the delivery. While they're not Clark employees per se, they're commissioned by Clark and delivering these raw materials and paper products and food ingredients. And then also the suppliers, well, those are the ones for whom the delivery are doing these deliveries. They're working. And so these suppliers influence the type of food, the quantity of food, etc. And then you have the managers of the system. You have the administration who runs the operation. And you also have the executive chef. I actually saw this person once, and someone referred to this person. So I know the person's here, and they had the chef jacket and the little thermometer on the sleeve and all that stuff. It looked really fancy. But that being the case, those are the ones who are responsible for the high-level decisions, strategic decisions, and the purchasing. And so the stakeholder impact is really important to analyze and consider, because that's going to tell you what information you need to gather about your system. And so the users, those are the ones, the students, they're missing the dining hours. Now, the food waste, if they miss the dining hours, they know how many students are on the meal plans. For which meals, 20 meal plan, 14 or 7, and they know how much they should prepare, okay? So if you're missing dining hours, well, that food is perishable and it goes to waste. Or maybe students come in to the dining hall, the users, they try the food and it's really not my thing. They don't eat the food, or don't eat all of the food, or don't eat much of the food. And that can be for a number of reasons. It could be maybe the quality is not what the student or consumer prefers. Maybe the preference is wrong, right? You're used to spicy food and it's not spicy, or the food's too spicy, you're not, and you don't like spicy food. Or maybe it's the quantity. Maybe it's a portion thing where the portions are way too big and you just can't eat as much as they're putting on the plate, and a lot of it goes to waste. For the operators, well, the operators might just be preparing too much. There's a mismatch between the expected people in the dining hall and those who actually come. Maybe there's a lapse in preparation. Something's going wrong with the process and things aren't turning out as they should be. Perhaps there's insufficient ingredients. There are things they really want to make, but they just don't have the raw materials to put that together. And then also might be overworked. There's too few staff for the types of prep work they need to do, and that impacts the quality of the product. Okay, any questions? Does that make sense? And so then lastly, the managers, right? Maybe there's an issue with the orders. Things aren't coming in time, things aren't spaced apart. Maybe there are inadequate options. They're not ordering as much variety as they should, or the staffing decisions are obsolete relative to the amount of staff they should have in the dining hall. It could be an issue with the supplier. Some institutions, especially state institutions, you're locked into certain state vendors and you can't go off and buy from a vendor if they're not an authorized state vendor. So you're limited to what they offer. And so all of these are considerations between the three stakeholders, the users, the operators, and the managers, that could impact this idea of food waste. And so now that you have these considerations, now you need questions about the impact. And this is leading to what you're going to measure. You're going to go off and build a survey and execute this survey, collecting data based on these impacts. Any questions so far? Does that make sense? And so for the users, you might ask them, what is your schedule? You need information about their schedule. And of course, you're going to compare that to the dining hall. And then you see, okay, based on the schedule, these are the potential misses for the dining hall. And you can actually measure that and check to see if particular meals or at during particular times, if more waste is produced or if more food is produced. That's not suitable for the amount of people that come in. How often do you miss the dining hall? You can just measure that. Every Wednesday, right? Because of X, Y, and Z in my schedule. When would you like to use the dining hall? Asking for preference information. Everybody has in mind his or her schedule and what would be optimal. Maybe the hours are not sufficient in that span of time between the early afternoon and the early evening. Maybe there needs to be more coverage. How do you like the food? Yes or no, that's a binary thing. Maybe you don't like the food. Does it satisfy your dietary preferences or your dietary needs? If you're vegan and everything is non-vegan, of course you're not going to eat the food. If you have nut allergies or tree nut allergies and they can't guarantee that it's not contaminated with tree nuts, you're not going to eat the food. So asking those things. Are the portions adequate? Maybe it's too big. Maybe it's too small. Well, too small doesn't cause food waste, but maybe it's too big, right? Which can lead to food waste. For the operators, how much prep time do you need? Prep time is very significant. Everything has to be washed and chopped and diced and sliced before it's cooked. Do you have the ingredients that you would need or you would like? Maybe there's an issue with the ingredients, a mismatch between those that do the ordering and those that do the prep work. Are you adequately staffed? Because every frontline employee will tell you whether they have the personnel that they need in order to carry out what they're trying to accomplish and hit their goals. For the managers, how do you design the menus? How many staff do you believe are needed for breakfast, lunch, and dinner shift? Because there might be a mismatch between what management thinks they need and what the employees know they need. Is your budget adequate, right? Because the folks that plan for the dining hall, they don't set the budget, right? They work within a certain budget and they have to do the best they can. From where do you order? Maybe it's a sourcing issue. Perhaps if you went to local farms within the state, you might get higher quality food more regularly. When do you order? It might be a timing issue. Who are the vendors and is it fixed? So all sorts of questions you can ask these three roles, the users, the operators of the system, and the managers in this example, to try to gather data or use it to shape how you issue your survey. And so I'm not going to go through all of these because we only have about 5 more minutes. But you can ask these questions and design survey questions, and some survey questions are going to be categorical. For example, for the operators, they know what roles they have in the kitchen, in the back of the house, as well as in the front of the house where you do the plating and putting it on the trays. I worked in dining services as a kid when I was in college, or not kid, as a young person, I shouldn't say kid. And so you can have categorical types of questions, binary questions, numerical questions. How many times a week do you miss your meal plan? And then some items you measure directly through your survey, but other items you compute by transformation. And so if you know how many meal swipes per week someone has purchased for a semester, and you have access to the swipes, you can calculate what percentage of their weekly swipes are going to waste that they're not using, right? And so this is just to say there's data that you collect directly, but there's other derived data that you calculate from sources by putting them together. Any questions about this? Does that make sense? All right. And so I won't do the measurements for all the 3 roles. I'll leave that to you on the slides. But that's when you have control over your data. You can issue surveys and you can shape your surveys to get the types of data that you believe will help you answer these questions. But it's important to have an understanding of who those 3 roles are: the users of the system, the operators of the system, and the management of the system. Okay. And so there's the other case where you have the data that's just given to you. Now, in that case, you don't have control of the sampling, and you effectively, in a statistical way, you have to beg the data for that information you need. And so with that, you still think about your population because you don't get to design it. It's just given to you. You don't get to place the samples. It's just given to you because you're dealing with an existing data set. But you still go through that exercise based on the data set and based on the domain from which the data set originates. You still think about your hierarchical population because this is going to help you to identify the various principals, the users, the operators, and the managers in order to try to compute transformations on the data, i.e. beg the data for what you need in order to enterprise to answer the questions. Any questions about this? Does that make sense? All right. And so you study the problem, you study the data, you design your population, and then you use your understanding of your population design to transform the data to get that information that you need to make your statements about the system. And so you still go through this exercise, but you don't have control over the data. You can just look at it, but you can still use this idea of population design and those three roles, the users, the operators, and the managers, to shape how you transform the data in order to answer questions about the system. Okay, any questions? No? So I will end with this, an example, and we'll talk about this example. It's a real example. It's a big example about New York City. So, nope. Okay, so New York City. New York City is the largest city in the United States. It has a land mass of 300 square miles, and it's a really dense population. Almost 30,000 people per square mile. That's a lot of people. And so when you have so many people in one place, when you run out of latitude and longitude, so-called X and Y on the surface of the Earth, you have to go up. You have to go up in Z. So if you go to New York City, you'll see lots of huge skyscrapers and buildings housing apartments because you just can't fit all those people on the surface of the Earth. The population is about 9 million, and the growth rate, it's modest, but it's still okay. The average household income is just over $100,000, and that might seem like a lot. What it is in some locations, but in New York City, that $102,000 doesn't buy you as much because supply and demand makes things much more expensive. It's a very expensive city in which to live. The poverty rate, and this is more an indicator of how expensive it is, in spite of this average household income, and a better metric is the median, which you all know now. The poverty rate is 17%. So there are a lot of people who are struggling in spite of what the median and the average and the quartiles are for the salary. And so because there are so many people, New York City operates 24/7. In fact, I remember seeing a documentary where someone enterprised to go out at different times during the night to see what you can do in New York City. And you can book travel, you can go grocery shopping, anything that you can do in a normal day, you can do in the middle of the night in New York City. And so owning a car, therefore, because of massive congestion on the city streets, owning a car is very, very expensive. In fact, having a place to park, which you often have to rent, is oftentimes half to 100% of the cost of an apartment or a place to live. And so for that reason, public transportation is the glue that makes it all work, be that modalities, subway, train, or bus, but taxi is the big one. Now, more recently, these rideshare companies like Uber and Lyft, New York City has become sort of the epicenter of the fight between traditional cab companies and these ride-hailing companies. And so I will end there, and we'll pick back up. Stay tuned on Wednesday, and we'll talk about the Taxi and Limousine Corporation and take a look at actual data that's reported on a monthly basis about rideshare and the yellow cab company. Okay, so I'll see you all on Wednesday. Right on time.